Hello everyone, this is Eric from Pipeline Security. So today I'm going to talk about object storage, direct upload optimization, mainly about skipping the copy step every time a file is uploaded to object storage. So the problem to solve here was that we were encountering problems with large files being uploaded to object storage because after Workhorse uploads to a temporary location in the bucket, um, the Rails, which are more specifically Carrierwave, would move copy plus delete this file into its final location. So it's like, and this is problematic in case we're in the fog driver for the specific object storage, like AWS is not optimized for multi-part uploads. So for large files, this would be very slow and eventually can fail the Rails process. So as a high-level sequence diagram of the current flow without the skip copy. So runner would upload, specifically this for the artifacts, right? This fix for now that we're doing is we're gonna roll out for artifacts specifically for now. So for example, the runner would upload the artifact to post, it will upload to the API artifacts endpoint, which will be intercepted by Workhorse. Workhorse would then first initiate an authorized call to Rails, and then Rails would return all the object storage related information and more importantly, the upload path where object storage would then upload to, where Workhorse would then upload to object storage. So in this case, Rails would return the object storage temporary path, and then Workhorse would use that file, upload path, upload path. It would upload the artifact to that temporary upload path to object storage. Um, and then after it completes the upload to object storage, Workhorse would then hit the Rails endpoint to finalize the upload, which would then internally the Rails would create the job artifact record in the database and whatnot. But at that point in time, when it saves the job artifact record to database, it would trigger Carrierwave's default behavior of moving the file from the temp uploaded path to its final destination, which is the part that we're trying to eliminate in cases for object storage direct upload. Um, so how do we improve this? So in many cases for object storage, this extra copy delete step is unnecessary because first it's the file is uploaded in the end to object storage. It's just that right now Workhorse is uploading the file to a temporary path. So our goal is to use that same direct upload behavior, but instead of uploading to the temporary path, we will upload to the final path instead. So this is how it would work without the copy step. So the same as runner posts the artifacts, Workhorse authorizes, uploads to object storage, but in this case, um, the Rails authorized endpoint would then return the final upload path instead of the temporary path. So that once Workhorse finalizes the upload, Rails would determine if this file has been uploaded to a final destination already, then it won't um, trigger the Carrierwave's default behavior of copying and moving to a final destination anymore. So at a high level implementation detail, I won't go through all the code here. I would include the link to the slide so that you could, if anyone's interested to look at the code and more specifics, can visit these links. But at a high level, this is what we did here overall. So first, we added a new feature flag so that we can control this and observe and slowly roll out the feature for artifact uploads. So we have this new feature flag, and if this feature flag is enabled, then when Workhorse authorizes for the upload, Rails would use the final upload path pattern instead of like using the old temporary random path generated. Um, we also introduced a new upload path hash path pattern, which will I would show later in the demo of how it looks like. And then upon authorizing an upload to final location, we will track that upload using a Redis hash. So once the upload is being finalized on the Rails side, right, we will check in the Redis hash if there's a matching entry for that given upload. And then if there is one, then we would bypass Carrierwave's default behavior of moving the file from temp to destination. You can see the details about how that was implemented in the links here. Um, and then because of this change, we had to prevent workhorse default implementation or default behavior of deleting the uploaded object from object storage, because initially without this change, workhorse would always issue a delete to object storage because like you would assume it was a temp upload anyway. But in this case, we don't want workhorse to delete the file uploaded because already uploaded to the final destination. So this can result to stale objects in rare occasions wherein for some reason workhorse completed the upload to object storage, but then on the Rails side, upon finalized step, it failed for some reason. And that would result to like a stale object. So we together with these changes, we added a cron job that would like regularly check for stale uploads and delete using the Redis hash, delete the Redis entry for that stale upload and delete the related, if ever, object from object storage. So I will do a quick demo of how this works. So first, as you can see, let me see, I'm not sharing my, I'll stop the share for now. Share screen. Okay, so I have a test project here locally. And we will just retry this job that would upload a generic artifact. But on my Rails console, the feature flag is disabled, so we can show like how it behaves right now without this optimization. And we would on Minio, we would observe the calls or commands that it would generate to see that it's actually indeed copying and deleting the file from temp to file destination. So I would retry this job. And here there, created an artifact and uploaded. And you can see here in the trace of commands sent to the object storage, we have the copy here, and then there's the delete. So this is Carrierwave doing this, and we can check for the path. So that's the hash path generated in. So currently this is the pattern for artifacts where it includes the project ID, the job artifact ID, and whatnot. Um, and we can browse the artifacts. So in this case, this is 75, 7858, 5F, 30, 29615. So there's the artifact that has been uploaded. Um, so that's how it works right now without the optimization. Now let's enable the feature flag Okay. I'll stop. So here I'll watch again. This time we would retry the job. We should. We're expecting to not see the copy and delete anymore in this case. Done. So there, no more copy and delete. And if you wanna see the path generated, oh no, that one is the metadata. Sorry about that. So here's the new pattern wherein it includes like the final prefix just to like um indicate that this file was created through that new code. Um, Note that we still create the file or the object under the root hash of the project ID so that we can in future cases wherein there's a need to like issue an object storage delete based on a prefix pattern, we can still delete um, manually all objects from under a specific project. And to see that this thing still works, we can browse. The file is still there. And see the so here's the newly uploaded artifact. That's final CA5F6 F6. So you notice the file name is not artifacts.zip anymore. We don't use the actual file name anymore. We always generate a random unique um, file name for each upload. And then, but in the database, the job artifact record will still have the original file name so that if we decide to, for example, download the file, it will still show the original file name, which is artifacts.zip. And that's it. Um, for anyone who's interested to look into this more deep, the more specifics and history, here are links to the main issue. The next step, right now, it's not enabled yet in production, so I'm still working on the rollout issue, and then here are the rated MRs for this. So yes, um, thank you, and if there's any questions, feel free to post comments or whatnot on the issue or on our Slack group channel.